Hello everyone, it's Samir here, and today we will look at a problem from coordinate geometry, specifically parabola, in which we will use a concept that is not that often used in most of the problems. Okay, so let's see the problem. It says that let y equal to 3x minus 8 be the equation of a tangent. Okay, so it's a straight line equation of a tangent at the point 7, 13 lying on a parabola whose focus is at -1, -1. Evaluate the length of latus rectum of the parabola. So we have to find the length of latus rectum. Okay, and it's some general parabola can be tilted, cannot be tilted. So in such kind of situations, we should avoid drawing the parabola as per the coordinate axis, the real coordinate axis, because it is not going to help us visualize the problem in any proper manner. Okay. Rather, what we should do is we should make the parabola and mark these points and visualize it in a standard manner. Okay. So the first step would be to draw a proper diagram. We don't draw axis and we compare with a standard case. Okay. And for finding latus rectum, what you will need is the latus rectum is 4a in a standard parabola. And to find it, you will need either the distance between focus and vertex or focus and directrix. Okay. So we'll need to find one of those and then we can find the latus rectum. So first we draw a proper diagram of this problem. So here we have drawn a general parabola. Okay, it's not as per the coordinate axis. This is the axis of the parabola, not coordinate axis. Okay, and we draw a directrix here. So from this in the problem, this point focus is given. A point P on the parabola is given on which we have drawn a tangent. Okay, and we have drawn a directrix. We have connected this point with the focus and dropped a perpendicular on the directrix because we know that the distance of point from focus and directrix are equal in the case of parabola. Okay, so our next task would be to use a concept that the image of focus on the given tangent lies on the directrix. Okay, the image of focus on the tangent lies on directrix and it is the same point. Okay, it is the same point which is foot of the perpendicular from the given point. Try to prove that the image of focus on the tangent will lie on directrix and will be the foot of perpendicular from this point. Okay, so we take these two triangles. Okay, PMN and PMF, PMN and PMF. In this, you know that PF will be equal to PN. This is the property of the parabola. FT will be equal to FP. FT is equal to FP. We know that FP for a point is x plus a in parabola. In any parabola, the distance of point from focus is x plus a. Okay. And the distance of this focus from this point where the tangent meets the axis is also x plus a. So, since these two are equal, this angle FTP and angle FTP, these two angles will also be equal. Angle FTP equal to angle FPT. Now, we also know that angle FTP will be equal to angle NPT because this one and this one, they are alternate interior angles. So these two angles are equal because this is isosceles triangle and these two angles are equal because they are alternate interior angles. And PM is common side in these two triangles. So these two triangles, PMF and PMN are congruent. Okay. So by CPCT, you will get that MN and MF should also be equal. And since this is a straight line and these two angles should be equal, so each of them will be 90 degree. So angle PMF is 90 degree. Okay, and these two are equal. So this proves that N is mirror image of F on the tangent X. Now our next task is to find the coordinates of this point N. Okay, so for this we will use how we find the image of a point on a given line. Okay, so to find the reflection of point minus 1 comma 1 minus 1 comma minus 1 on the line y equal to 3x minus 8. So we first find this distance. So the perpendicular distance comes out to be root 10. Okay. So this is the distance root 10. So the distance of image from this point would be 2 root 10. It would be twice the distance. Okay. So you know that the distance of image from minus 1 comma minus 1 is 2 root 10. Next we see, because I'm using parametric form of line to find the image. So I've found this distance. Now I will find the direction in which this line is going. So the slope of the given line is 3. The slope of given line is 3. So slope of its perpendicular would be minus 1 by 3. So the tan theta of this is minus 1 by 3. So based on this tan theta, we can draw a triangle 1 and 3 as its perpendicular and base, and its hypotenuse would come out to be root 10. So we saw that since tan theta was coming minus 1 by 3, sin theta would be 1 by root 10, cos theta would be 3 by root 10. Now, which among them would be negative? Okay, this is very important to find out. Now, we are moving from this point minus 1 comma minus 1 towards fourth quadrant. This line will come below. In real coordinate plane, it will be below this point. Okay, so we will be moving towards fourth quadrant. So cos theta we will take as positive and sin theta as negative, and we'll find the coordinates of the image of focus. Okay. So what we do is the image would be minus 1 plus r cos theta. Your r is 2 root 10 and cos theta, and y coordinate would be minus 1 plus 2 root 10, which is r sin theta. And the value of cos theta and sin theta we put from here, taking cos theta as positive 3 by root 10 and sin theta as minus and sin theta as minus 1 by root 10. Okay. So after cancelling out these root 10, the coordinates that we get is 5 comma minus 3. So we have found the coordinates of n. N was the point which is image of focus F on the tangent. Now we are seeing the same figure again without the parabola. So the coordinates of n are, so the coordinates of n came out to be 5 comma minus 3. Now we need to find the slope of this line. So we can write the equation of directrix, find the perpendicular distance between directrix and focus. Okay, so this is 2a. So latus rectum would be twice this distance. So how do we find the slope of directrix? So slope of directrix we can find by finding the slope of NP, because directrix would be perpendicular to this. So slope of NP we find by knowing the fact that these two angles are equal. And we know the slope of this line tangent, which is 3. And the slope of line joining this point and F is 7 by 4. So we first find this angle. So this would come out to be the angle between FP and MP. The angle between FP and MP. So we apply tan theta equals to 3 minus 7 by 4 upon 1 plus 3 multiplied by 7 by 4. Okay, which comes out to be 1 by 5. So tan theta of this angle is 1 by 5. So tan theta of this angle should also be 1 by 5. Okay, what we do now is we apply the same tan theta between the slopes of this NP and MP. Okay, so we know that we assume that let the slope of NP be m. So m minus 3 upon 1 plus 3m should be 1 by 5. So this will give you two values. One will come out to be 7 by 4 again, and the other value of m you get as 8. So we get that the slope of NP will be 8. So the slope of its perpendicular will be minus 1 by 8. Now we know the coordinates of n and also its slope. So using 1-point form, we can write the equation of n. We can write the equation of directrix. So the equation of directrix from the 1-point form would come out to be y plus 3 equal to minus 1 by 8 into x minus 5, which on simplifying gives us this equation. Now the only task left for us is to find the distance of focus from this line. Okay, so we again apply the formula for finding perpendicular distance of a point from a line. So we put minus 1 comma minus 1 in this line, divide by root 65. So the perpendicular distance of focus from the line comes out to be 10 root 65. Okay, comes out to be 10 root 65. So the latus rectum should be twice this length. So the length of latus rectum would be twice the distance between focus and directrix, which would be 20 by root 65, which on simplifying would give you 4 root of 5 by 13. This 5 by 13 whole is under root. So for more such unique problems and unique approaches to solve them, keep watching further videos. See you in the next video.